What's up? I'm going to be doing question 8 of 15 for week 6B homework rotational kinematics. Um, so, oh, I can't see. There we go. Sorry, my camera's blocking it. Um, we're going to make a new sketch pad here. Boom, boom, boom. And we're going to do question 8. A baton twirler throws a spinning baton directly upward. As it goes up and returns to the twirler's hands, the baton turns through 4.09 revolutions. Ignoring air resistance and assuming that the average angular speed of the baton is 2.41 revs per second, determine the height to which the center of the baton travels above the point of release. So, in this situation, we want to be using T equals number of revolutions over revolutions per second. And that's going to be 4.09 over 2.41. Correct? Correct. So T equals 4.09 over 2.41. And we get 1.697 seconds. Time with the SI units of seconds. Then we want to get the T for how far it's going up, the time of it going up. In this situation, we want to grab this right here that we got for T and put it on top. 1.697, and we're going to put that over 2 because we want to cut this in half. It's going to be the half time. And this is going to get us 0.8485 seconds. Time obviously is going to be the SI units of seconds. Then we want to use this equation right here. H equals 1 half gt to the second, and this is going to be the t of up. And now we just fill in the now we just fill it in. So h is going to equal 1 half 9.81. This is gravity times the time that we just got, 0.8485 seconds, and it's going to be to the second. And the final answer of this calculation would be 3.53 meters. 3.53 meters, and this is the height with the SI units of meters. That's going to be question 8. Oops. And for the second question, I chose question 11. A Ferris wheel rotates at an angular velocity of 0.29 rads per second. Starting from rest, it reaches its operating speed with an average angular acceleration of 0.035 rads per second squared. How long does it take the wheel to come up to operating speed? We're going to be looking for time here in this situation, so we're going to be using the angular kinematics equation. So that's going to be W equals W 0 plus and t. That's the equation that we're going to be using in this situation. And in this situation, the initial angular velocity is going to be it's going to be 0, just 0. So the initial angular, which is this, well, okay, hold up. We just do W 0 is equal to 0 rads per second. So in this situation, the SI units for W is going to be rad per second. The final angular velocity is going to be 0.29 as told us here. So that's going to be W equals 0.29 rads, and the W obviously going to have the SI units of rads per second. And the angular acceleration is going to be 0.035 rads per second squared. So this is just it's just like the same units as like same situation as velocity and acceleration, where it's rads per second and rads per second squared. But in this situation, it's going to be 0.035 rad per second squared. So the SI units being rads per second squared. And In this situation, it's asking for time, so we want to solve for t. So we want to rewrite this equation to make it so we're solving for t. So if we rewrite this equation, the angular kinematics equation, we write it to t equals w minus w initial w over, and there we go. And then we want to do t. Oh, excuse me. We just want to insert the numbers that we have here. So I like to make a list of what we have so far because it'd be so much easier to just insert everything into the equation once you have everything you need. So t is going to equal 0.29 farads per second. And obviously, it's going to be 0.29 minus 0 because the initial is 0. So it's just going to end up being 0.29 on top. Divided by 0.035 rads per second squared. And the final answer for this is going to be t equals 8.3 seconds. Obviously, time's going to be the SI units of seconds because the rads do get canceled out. Boom, boom. This is to the power of 2, so one S is going to be left on this side. And the final answer is going to be t equals 8.3 seconds, which is correct. And those are my 2 questions for week 6B homework, rotational kinematics.